Number 9. The quotient of a number and 5 minus 2 is 8. We need to translate these words to math. The first word we need to translate is quotient. Quotient means to divide. So let's write our division bar. Of a number. We don't know what that number is, so we can replace the term of a number with any letter or variable A through Z. I'll use X. So X represents a number, quotient is the division sign, and we write the fraction or the quotient just as we read it, in the order that we read it. So a number goes in our numerator, 5 is our denominator, minus, of course, means to subtract 2, is means equal, and then 8. You can also write this answer as X divided by 5 minus 2 equals 8. Number 10. Larissa is planning for a trip that costs $2,145. She has $952.50 saved and is going to set aside half of her weekly salary from her part-time job. Larissa earns $265 a week. How many weeks will it take her to earn the rest of the money needed for the trip? First, we need to take the cost of the trip, which is $2,145, and subtract the amount that she saved. I'm going to round to $953. So we subtract 5 minus 3 is 2. I can't subtract 5 from 4, so I need to borrow. I can't borrow from the 1, but I can borrow from the 2. So let's change this to 11, but I'm going to borrow 1 from it. So we have 14 minus 5 is 9. 10 minus 9 is 1. 1 minus 0 is 1. So she needs to save $1,192. Next, we see that she's going to set aside half of her weekly salary. So we need to take her weekly salary of $265 and divide that by 2 to determine what half of that amount is. So 265 divided by 2 is okay, I'm going into the next problem. So let's see. We're going to round this to $133 is what she's saving. So how long will it take her? How many weeks will it take her to earn the rest of the money? So we need to divide. We need to divide 1,192 by 133. And let's try 9 here. Because 133 won't go into 1, it won't go into 11, it won't go into 119, but it will go into 1,192 times. So let's guess and check. Let's try 9. 9 times 3 is 27. 9 times 3 is 27, plus a 2 gives us 29. 9 times 1 is 9, plus gives us, okay, so she'll need to save, and I know it's not exact, but she'll need to save for about, we'll say, 8 to 9 weeks. It's going to be more like 9 weeks. Okay, next question. Number 11. List 3 coordinates where x is less than -3. So we need to find -3, where x is less than -3, and y is greater than negative 10. So x is less than negative 3. So we're going to be working with this side of the coordinate plane. And y is greater than 10. So we can list any three coordinates. Your answers may be different than mine. So we can say that one of the coordinates is negative 4, and it has to be, y has to be greater than negative 10. So we can say negative 4, 0. We can say negative 5, 0. And we can say negative 5, 1. There's going to be a lot of different answers. As long as your x value is less than negative 3, negative 4, negative 5, and negative 5 are less than negative 3, and your y value is greater than negative 10. 0 is greater than negative 10, and 1 is greater than negative 10. Next question, number 12. List 3 coordinates that lie within the shaded region. So here's your shaded region. I can pick, again, your answers are going to be different than mine probably. I'll pick this point, and this point. So this point is 2, x value of 2, y value of 0. This point is x value of 3, y value of negative 1. And this point is x value of 4, y value of 1. Number 13. It's a two-step equation. Negative 5p plus 10 equals 75. So draw your line down the equal sign. We're not going to worry about the negative 5p. Let's get rid of plus 10 by taking its inverse. Its inverse is minus 10 or negative 10 on both sides. Let's bring down the negative 5. So this cancels. Let's bring down the negative 5p. Now, negative 5 times what number will give us 65? So we can divide 65 by negative 5, and we get negative 13. So p equals negative 13. Next question. A certain nucleus measures approximately, and that's a really small number, millimeters in length. How is this length expressed in scientific notation? So we want to, our first number in scientific notation is always a number between 1 and 10. I can make this number 2.8. That's a number between 1 and 10. And scientific notation always has times 10 as its correct syntax. And now I need to calculate my exponent that goes here. I know it's going to be a negative exponent because that's a really small number. Really small numbers are always negative exponents. So let's bunny hop 1, 2, 3, 4, 5, 6, 7 places. We have to move our decimal 7 places in order to make this number a number between 1 and 10. So the correct scientific notation is 2.8 times 10 to the negative 7 power. Number 15. We need to translate this phrase to a math expression. So a number, we don't know what that number is, so let's replace that with any variable a through z. I'm going to use x again. So x multiplied by 5, so times 5, and increased by 3, so plus 3, increase stands for plus, translates to equal 28. You can also write it as 5x plus 3 equals 28. And multiplication and addition have the commutative property, so I could rewrite this 3 plus 5 times x equals 28 and get the same answer. So either one of those would be correct, and there's more ways that you can write that as well, but we'll just talk about those three.